Okay, good. Press the button. Great. We start. Hello, everyone. My name is Nikolai. My co-host is Ilya.
Hi, everyone.
And this is PostgreSQL special series, which I call Open Talks. The idea is to record great talks, which were not recorded in recent conferences. And today we have a great guest, Hannu Krosing. Hello, Hannu. Sorry for wrong pronunciation. Hannu has Hannu has a very great experience, like Postgres since 1995, right? And great experience in Skype. I remember PL proxy. We used it when we needed to shard our Postgres databases quite long ago, and also a lot of activities in Postgres development itself, right? Including the topic we are going to talk about today, right? Vacuum. So if I'm not mistaken, you helped to develop ability for auto vacuum to process multiple tables at the same time, right?
Yes, this was, I think I looked it up even, it was 2005 when I sent the batch to the hackers list, and then there was some discussion, and then it took about a year, and it was finally committed at Postgres anniversary conference in 2006. More than a year later, it went to the community version, but we were using it all the time because we needed it. So this is
and now you
example. It's a good example of how getting patches in can take a long time, and
yeah,
also
well,
it's not that important thing.
I know how it works. It takes.
It was considering long time. I think now some patches taken even longer because they're more complex.
Yeah, but this was a really small patch actually, code-wise. It did I think maybe a few tens of lines probably. So it just added, fixed some oversights, and then made it possible to actually clean up multiple tables at the same time. So it shouldn't have been any way dangerous. So it didn't. After some initial advice and discussion, it didn't get too much other notice than somebody was sometimes asking. But in the end, I was sitting next to Alvar at some hacking session and saw that he was working on the same places, and then said just that please put this also in, and so it got in. So, but let's then start to it.
Right. Yeah, let's start. Just a couple of very small comments. Thank you for everyone who joined online. We have chat working. It will be recorded and replayed later. So please ask questions there. We will deliver questions to Hannu. And thank you for joining us again. And don't forget like button, subscribe button, bell button, everything. And comments, of course, comments under this video. We will be monitoring comments as well and try to answer everything. Thank you. Please, let's start.
So yeah, the topic will be vacuum and what to do, what not to do, what we have done. Okay, that is a quick background of me. Have been with Postgres since forever. Looked even before it acquired the SQL language, when it used PostgreSQL, which was instead of select, it's retrieve, and otherwise had different syntax. Was first DBA at Skype. The other things, invented PL proxy. That was the initial way to make Postgres infinitely scalable. I think they still use it, if they use Postgres at all now. They have been with Microsoft for quite a long time, so maybe they have figured out how to use, but I don't know. I have written 2 books. Postgres 2.9 admin cookbook, but I haven't been in the latest versions. It's mainly by Simon Weeks now, and I think Gianni Colli is the other author that they keep it going. Just recently it came out for Postgres 14. And then I did Postgres server programming, which basically was about that you should try to use Postgres because it's an amazing system, and don't use it as just a storage, use all the functionality. This is I was finally able to get the Chinese version, which is, I would say it's a pirate copy. I don't know that they asked to translate it, but it was translated by something called Chinese Machine Press. And so I was finally able to get my own copy. Amazon was agreed to send it to US, so I had some friends to receive it.
It's interesting. I remember we translated the first book to Russian very, very long ago. I hope it was licensed because it was organized by some publishing house. So just a comment, but I'm not 100% sure it was licensed. So
yeah, it's anyway. We are more than happy also for unlicensed copies because it was never kind of primary for earning money, because writing books is hard, and in Postgres books you are very unlikely to get your money back or your money for your time spent. So it's also I'm very happy with Simon and Gianni that they keep up doing this, and I'm pretty sure it's not for money, but just to have a good source of info. Yes, and then I was quite long time with second quadrant, and then now for last 3-4 years I have been with Google doing Postgres, mainly Postgres related things. So, and the talk itself is about the vacuum, what it is, also how it relates to Postgres version of multiple version concurrency control, also why it can go wrong, when it can go wrong, what happens when it goes wrong, and how to avoid it not going wrong. So, and then I may cover some things we have done at the Cloud SQL version to make things easier to manage. First, that it doesn't go wrong, and also manageable when it does. These things we are planning to give back to open source version. Just we haven't had time to do it, so there is nothing else. Okay. Okay, first about then vacuum and MVCC. I don't go too deeply. There is a very good documentation on Postgres internals. The link is here. And then basically, Postgres does multiple version concurrency control, which means that every time you update the row, it makes a new row, and then it keeps the info about transactions which inserted the row and which removed the row in fields in each tuple. And so it is it keeps all the bookkeeping all the cleanup works out of the main work stream, which can make Postgres really fast. But if you neglect cleaning up for too long, then you can have problems. Yes, and then one interesting thing that Postgres version of MVCC, it kind of accidental, even not really, but it was a very good clean architecture before MVCC, but it started out as temporal database. So the idea was to keep all old versions, and up to Postgres version 6.2, you could even put in your queries that I want the data from this table at this time. So instead of xmin and xmax, it had tmin and tmax, which were actual timestamps. And this made this temporal thing very easy, but it also made sure that the updates, you could only have a single insert or update or single transaction running at any time, which made it really badly scalable. And so there was a lot of work done, and end result was the current version of Postgres MVCC that is hugely parallelizable, very good performance, but it has lost this temporal thing. You can't currently ask for old data. There are several efforts to bring it back in multiple ways, but none is yet there as in the core. There are extensions that you can use for this functionality. Yeah. And there has been lots of small improvements that make some use cases need less vacuum, less cleanup, because it does it online. But the basic architecture is still the MVCC, which needs the upkeep. So what does vacuum? And the process that does this cleaning up is called vacuum. There is a manual vacuum and auto vacuum. It does two things. So it does it removes the old rows. It frees up the space that is used by the old rows in the tables, and then also it removes all the pointers to these rows from indexes. And it is a bit complex multi-step process to make sure that if it crashes halfway through, then everything is still correct. So it's more complex than it's written here. It's actually first collects rows, then it cleans up the indexes, and then it goes back and removes them from the heap tables. And the part that can actually free up the space, this 32-bit or 2 billion rows, 2 billion transactions, is freezing. And freezing basically tells in each row that this transaction is committed by setting a few bits. It used to be a special transaction number 2, but now, so you could actually, by just selecting xmin, you could see if it's frozen. Currently, this direct select still gives you a transaction ID, and you will not see it as frozen. You need to use some extensions that can show you the flags. And it actually could even be something else in the future, but still keep the basic architecture of Postgres MVCC, where there is no rollback logs or anything like that. It's everything is kept in the main data table and then later cleaned up. So what can go wrong? There are two things. One is if you don't clean up the old rows, then you will get bloat. Bloat means that you will have lots of unused rows from updates, deletes, also transactions that got rolled back. And so instead of 1 megabyte, your table can be 10 megabytes if you have done 10 updates and for some reason the rows are not cleaned up. And when the freeze is failing, then first the Postgres starts by default at 200 million rows. It starts aggressive vacuum that blocks all DDL, and this can have bad results. You can't add indexes, you can't drop columns, add columns. And if you try, then other normal queries, selects, updates, deletes can then be waiting behind your DDL, so you can have problems there. And if you then still don't clean it up for next 2 billion rows, then you get the thing called wraparound, which means that transactions that would be in the past will suddenly show up in the future. It used to be an actual problem in very early versions of Postgres. Currently, Postgres detects this, and 1 million transactions before wraparound, it actually stops accepting new write transactions, which means that it just, as a user, you see a database that is suddenly read-only, and every time you try to do anything that modifies the data, you will get error, which says that you are. But everybody still calls this wraparound, even though it's a wraparound protection that doesn't let you do any modifications. Yeah, but I have often heard that this is a big problem with Postgres, and some even say that they can't use it because of that. Actually, it's not really big. It's just a side effect of a very good design, which keeps all the housekeeping out of the critical work path. The concept and is very, very simple, which means that it can be programmed in a very efficient way. One thing that is there in Postgres is that both commit and rollback are really fast. They just need to log the fact that the commit or rollback happened, and then set a few bits in commit log. If you did the MVCC the other way, with rollback segments, rollback logs, then rollback could take as much or even more time than the whole work that was done in transactions. And I have seen this happening in MySQL when people try to do a large delete and then canceled it, and then the cancel took same time as the delete had been already running. In Postgres, you would be you still haven't cleaned up anything, but the rollback or cancelled query will cancel immediately without any extra work. Also, you can do large data loads in parallel with large analytical queries without any slowdown, because there is no chasing moved away data in rollback logs. And,
can I comment here? I
yes,
have very good use case. This is particular use case when we perform a lot of deletes in one transaction. It can be a single command, but deleting many rows, and then we roll it back. This is very interesting, and I use it for various kinds of checks. For example, if we have default checkpoint settings, we can see how our IO system will work, how checkpointer performs a lot of IO. And the good thing here is that so it basically writes a lot of xmax values to tuples, right? And then just marks this transaction as rolled back. So this xmax value becomes equivalent to 0. So like tuple is still alive, but we produce a lot of writes, a lot of wall writes, and we can check. And the best thing here, what I like with this particular workload, we can repeat it, and our physically the table will be the same. So we don't produce new tuples. We have exactly the same. We just write these xmax values. If this is like, we can repeat for example, adjust max wall size, repeat again. And this is exactly what I use for checkpoint tuning, actually.
Yeah, and it's a quite clever use of this, indeed.
Right, and our previous episode 1 week ago with Amit Kapila about logical decoding and replication, I also use it there to verify saturation of wall sender, because again we write a lot of wall data, but on the recipient side we don't do anything because of rollbacks, right? So logically we don't do anything, but we can see how our wall sender reaches 100% CPU quite easily. So it's a very small effort, this kind of workload, but it's kind of useful for DBAs to apply and use in various kinds of checks. So and we have a small, maybe not small, another question. So it was a comment. Sorry, it was not a question, but we have a question in chat. Question is, do you expect that in the future all page maintenance will be fully automated and Postgres and vacuum command will be obsolete for good, leaving only GUC parameters, only settings?
Currently, there seems to be work being done for moving to 64-bit transaction IDs, and it will solve this wraparound problem. You won't get freezes. but you still may want to manage it more than auto vacuum does. So that I don't think it's going completely away, but more and more of it will be automated, and as automation improves. So definitely there is work going on, and there are other ways. And internally, the vacuum needs to happen. And Postgres has a nice thing that if there is some internal things, then most of the time you can access them also for some fine tuning and special cases.
But for example, if we have like at night, we have much fewer TPS compared to day, we might want vacuum to happen at night, right? This is a very popular idea usually. Yes. And automatic vacuum is not so clever to postpone the work to night. Nights.
I can imagine that at some point, if somebody puts the effort, it could actually look at the load and then adjust its vacuum workload based on what else is happening. So lots of it will probably be more and more automated. But again, until this is happening, and as with any automation, it can go wrong. So I'm sure that it will still be possible to help it out manually in case it doesn't work the way you expect. But it is a thing that is needed less and less. Most of the time it works as expected, and you really don't need to know it. But as we get in some next slides, it can also, because it's not that important anymore, then when it goes in a bad situation, then it's also something that you really don't like to have to deal with.
And what do you think, actually, is there any hypothetical use case when we do not need to do vacuum at all? Is it possible some sort of thing when we actually better switch off auto vacuum and do some maybe a bit of manual vacuum instead of auto vacuum?
If you have just very large data loads and the actual number of transactions is not that big, then you probably don't need to do vacuum depending on your queries, because one thing vacuum does, it also keeps up to date the visibility map, which is in Postgres essential for index-only queries. So for that, you definitely want it to happen. But if you are sure that your queries can't make use of index-only queries, so you are doing some analytics that always needs to do full scans, then it could be that you can completely do without it. But again, just switching it off, I wouldn't recommend it, because auto vacuum also takes care of analyze, which is quite important thing. And I have seen one quite visible case where not turning auto vacuum off, which in early days of Postgres was actually sometimes recommended for high workloads, caused a very bad and public situation where on TV the election results were not possible to show, because the system was analyzed at empty state, which made the plans based on zero-length tables. And once the data came in, they become less and less efficient until at some point they become so slow that they just couldn't finish in minutes. So at least the vacuum side, either you must manage it very well yourself, or just currently I would always say that keep the auto vacuum on. If you need to do something special, then do it per table basis. So you can alter table and then set vacuum parameters and then manage these manually. But don't do it wholesale. Don't do it for all tables.
Yeah, and currently, actually, it's even better, because now we have insert factors for auto vacuum.
Yeah, in the latest versions, I think it started in 14. You can also do auto vacuum based on inserts. Earlier, you had to do, in this case, manual vacuum if you wanted to inserts also trigger or vacuum or freshly loaded tables to have vacuum.
Right. It's not only about statistics, like auto-analyze part of auto vacuum, but also about index-only scans. Very important after initial load.
Yes.
To have it to make queries faster, right?
Yes.
Good point.
There can be some corner cases where you know that you don't need them, but in general, it is good to have it.
Yeah.
So, okay, so let's now tell mainly in what cases vacuum can't do its work. So there are multiple things that actually make vacuum less efficient. It can't remove all those. And the basic thing is that vacuum, because of multiple version concurrency control, you can't remove the rows that are still visible to some other backend. And you also can't freeze or mark them committed for all if there are some transactions for which they are not committed, which see the snapshot before the transaction was committed. So for these ones shouldn't see the row. And there are 4 main categories that can cause this in Postgres. One is just simple long transaction. Either you are running a very long query or somebody did start transaction, did some work, and then maybe went for lunch and then didn't commit or roll back the transaction. Then the other type of long transaction is two-phase commit, which is a SQL feature where you can first prepare commit and then later the prepare does all the checks, but it doesn't actually make the row visible to others. So it checks consistency, but it doesn't still make the isolation feature. So it's still isolated from all other backends. And in the case of Postgres, you have also replicas. If you set the hot standby feedback to on, then these long transactions can be also on replicas, which means that even a long transaction on replica keeps vacuum from working on the master. And the 4th one is replication slot. If you just create a replication slot and replica actually goes away, then it still can hold back vacuum, because there could be something. I'm not even sure what the mechanism is, but I know that stale replication slot also hampers a vacuum's ability to clean up old data. Probably because just the application is at the state that needs an old view, especially logical application, and then you can't clean up from that time. And these all cause both bloat and wraparound. And also sometimes it just happens that your workload is so heavy that the vacuum can't keep up. This can happen especially in case you have a large table or lots of indexes. And if it starts and the index cleanup is one of the places for vacuum where it's quite slow, because it collects all the deleted rows and then it does full scan of all indexes. So, which seems a weird concept, but basically it does similar thing to sequential scan on tables for index, and then for each index pointer it checks if it was deleted, and if it was, then it's removed from my index. And the last one is something that I hadn't actually seen before Google, where there are really large number of databases running. I had before seen lots of databases during my consulting, but nothing compared to what we have in Google. So, and we have had a few times where somebody makes a temporary table, and then this connection is open so long that the wraparound happens. And because temporary tables are not auto-vacuumed, then the result is that they still hold back this vacuuming horizon from before what you can delete. And then in temporary tables, you get transaction IDs, which are so old that they cause this wraparound protection to kick in. And even though normally temporary tables are cleaned up when you close the connection, in this case, it can't clean them up because the wraparound protection is already active and it can't remove them from PG class because it can't get a transaction to remove them. So you get this chicken and egg problem that removing them would solve the problem, but you can't remove them because you have this problem.
I have a question on the previous slide. So you mentioned the word horizon. I wonder why, like, usually if what I saw in various monitoring systems, people usually tend to monitor long transactions, state of slots, and so on. I wonder why, like, isn't it better to define only one single metric in the cluster? Like I usually call it X-min horizon, maybe just some vacuum horizon or something. And regardless of the reasons of why it's so far in the past, we can just monitor it and define some thresholds for alerts, and then DBA or SRE can react to them, right? And in this case, we don't care about particular reasons, but we already see that we have this problem. Then we can troubleshoot.
Yeah.
Actually,
in Cloud SQL, we have these metrics, but it's not very prominently visible. So only people who already know about the problem can look at it. They find it.
Right.
And then
maybe changing the language from long transaction to this horizon. I see it in hackers all the time, but we don't have some function and we don't have it usually in monitoring. This is, I think, something that can be improved. And
yeah,
in
I
this
think
case,
some other monitoring systems also have it, but again, this is some metric you already must know about it. And most people who get hit by this are either new to Postgres, coming from some other systems which doesn't have this specific problem, or they have been working on smaller databases where again the vacuum keeps up nicely and then maybe scaling, and then it is something that in general auto vacuum works so well that you most of the time you don't need to know about it. It just happens automatically. But when it happens, then it's really unpleasant.
Basically, the situation changed quite a bit after 9.5. So basically, before 9.5, the case then even well-tuned auto vacuum can hit wraparound was much more common than now. Now, actually, to hit wraparound, you need to be extra smart, I would say.
Yeah, I actually put one slide in which tells you how to get to wraparound in about an hour.
Oh, so yeah, that's not
we had this discussion in Telegram chat and Twitter, how to simulate this problem. This is interesting.
So yeah, so if these problems happens, then what happens there? So one is that everything can be slowing down, especially if you have this lots of updates, and then this means that some queries may need to go through many versions of the same row to get to the one they want to see. And this, under normal circumstances, Postgres optimizes it away by putting hints in indexes if it already knows which rows are deleted for all, even without vacuum. But if you have this bloat causing problems, then it must keep all the old versions, and then just normal queries can become very slow because each of the queries must inspect all the rows from the full history. Yes. And yeah, then there's also just bloat to is minor slowdown. This is when just vacuum is not keeping up, but you don't have these blockers that force you to keep all versions. In this case, this hinting happens and index already in the indexes, you can see which rows are and are not visible. Then you have just bloat, but not that much slowdown. You can also have the opposite, that you don't have much bloat, but you can run in wraparound. This again, different type of workload can cause this, so that you just have not cleaned up. Maybe something goes back. You could even have been removing the rows so they don't cause bloat, but still have a wraparound. Yeah, then what I mentioned earlier, anti-wraparound vacuum, normal auto vacuum, when it sees that the user level DDL wants to get the lock on table, will just cancel and let the DDL proceed. If it's in this aggressive anti-wraparound mode, it doesn't do that, and this can cause all kinds of problems with changes or migrations or whatever you are doing that changes the table structure. And this, it's not just blocking the DDL, but then DDL in turn can block normal. An index or drop an index, then somebody does select, and this select will wait for this index to be either created or this query cancelled. So everything suddenly is stuck behind it, which of course means that you should be using statement timeout in your DDL if you do it on the live. So if it doesn't get locks fast enough, then it just cancels instead of blocking everything else. And the worst case is when you actually go into the wraparound, you can then be hours or even days in this cleanup mode, depending on your database size, machine size, size of tables that need cleaning up, and so on. And when this happens, then at some point you see this error that says database is not accepting commands to avoid wraparound data loss in database, and then it says database name. And then there is a hint, stop the postmaster and vacuum the database in single user mode. But this is something that you actually shouldn't be doing most of the time, because single user mode is, single user mode is something where you really don't want to do any work. It is really a Postgres running as a single command, reading input and then running a single threaded version of whatever it's doing. And okay, let's go back. And here I put also a quick info on how to get in about an hour to wraparound if you need it. So what I have been doing is you first, you create a table. Okay, I edited and now I'm in wrong order. You create a table, simple table with just one integer. You insert something there and then you prepare this transaction. And this prepared transaction, because it's not resolved, will keep vacuum from cleaning up anything. After that, you can create a function that will run in a loop, and it has a small exception clause which does just inserts. If you want this to be extra fast, you will run this insert on unlock table, which means that it doesn't create any log, but just runs at full speed doing inserts. You may even want to be even cleverer and always roll back it so that you don't even use much space, but you run in just the same page, and the local mini vacuum keeps the space. I think it will work. I haven't tried this one. This is speculation, but at least if you do exactly like that, then you will get something. Several hundreds, I think I've seen 700,000 transaction needs used per second. And for getting to wraparound in 1 hour, you need a little less than 600,000 per second. And the important thing to do is to set client min messages error and set the log min messages error, because last 10 million rows will generate, each insert would generate a warning, and then you will run in 1 hour, you get to the warnings, and then it takes several hours to just log the warnings and or read them from the console. So you must switch them off to setting your min messages to error. Then the last 10 million also goes in a few seconds. So
this is very interesting. We can master this capability, ability to put cluster on this of wraparound. We like, it's interesting that you use sub-transactions here, definitely, right? So begin exceptions at sub-transactions. So we did it differently. We used exceed current, but regular transactions. So nothing, no inserts at all, no data changes at all. Exceed current will generate a real exceed, real transaction ID, and we will just consume them very quickly. But I guess if we combine our methods, if we put exceed current to your PGSQL code to use sub-transactions, maybe it will be even faster.
Yeah, I can. You probably in newer versions where there are also procedures, then you could do just a loop that does current and then commit, or current and rollback. So you can't use it before, I think, 10, where you don't have procedures. Then you must send them from client side individually, which again, then you have the latency of sending the commands, even though you can probably patch them. But I think if you patch them, then they are run in the same transactions. If you put in the same string did twice, I think Postgres then makes this whole string in a single transaction. If you send these from PSQL, then PSQL passes everything and sends them as individual commands. But if they are in actual same string, which you can do, say, from Python and other things, I think it will be in the same transaction. So you really would need to send them individually in this case.
Okay, interesting exercise. Okay.
So yeah. Okay, yeah. So instead of single user mode, you should, and then vacuuming everything, you should actually check first if there are any vacuum blockers, and then cancel long-running queries, drop replication slots, and then find which database and which table is actually holding it back. So not instead of vacuuming everything, start with the tables that are actual causes of this wraparound. And if you have got it out from the wraparound, then go back and tune your system so that this doesn't happen again. And why you don't want single user mode? Single user mode is really unpleasant place to be. You don't get any logging. You have no idea how far into the system you are. The only way to guess it is looking at some disk usage or CPU metrics and try to figure out what it is doing. And it can be really frustrating, both when you are it's your database, or if it's a customer database and their multi-million-dollar business is down. Then it's sometimes even more unpleasant, because you would like to tell them at least when it's ready, but you have no idea when it's ready, because Postgres is just doing something. And even if you say vacuum verbose, then it's not verbose. You are still getting no progress report back. At least this is my experience. And there are other things that make it really unpleasant also. Is you need the amount for the write-ahead log, because no val rotation happens because there are no backends. So you need for the whole database amount, you need space to keep the write-ahead log, which means that you need, for a terabyte table, you need more than a terabyte of write-ahead log, especially if it has indexes. It could be several terabytes that is consumed during this vacuum. And in case you have replicas, then the replication is not happening, and all this needs to catch up after you finish. So whatever you can do to avoid the single user mode, do. And Yeah, and
I must say this is the best summary of big problems I ever heard, because we saw blog posts of big companies, big Postgres setups, very old ones, Sentry, then MailChimp with their service Mandrill, if I'm not mistaken. And they described this situation and many days of getting out of that problem. But this is the best summary. Like really, like it sounds terrible. So
yeah.
you need a lot of disk. You need to fix replicas. It's terrible, right?
Yeah, it is a really bad place to be when you need to deal with it. So yeah, okay. Here is also a list of these things that why it's not good. And also in latest versions of Postgres, it can do multiple index cleanups in parallel, which again doesn't happen in single user mode because there is no parallel processes running, which means that the whole thing that makes very large vacuums slower is even slower, because even you may have a really big machine, but you still will have a single process reading through all these things. And then this again makes it even slower than it would have needed to be. And one is that you actually, most of the time, you don't need to run single user mode. It's just wrong, the message there. Because vacuum nicely completes almost always in Postgres. I went back to before 9.6 and it did complete. It doesn't complete nicely in 8.2. I think I went back to 8.2 because this is where the split was done between virtual transaction ID and real transaction ID. But a few versions after that, still it didn't complete. I didn't get test all versions because I was not that interested in versions before 9.6. but in 9.6 you can just run vacuum, and it does the needed updates in place. The oldest transaction need and the oldest multi-transaction ID, they are updated in place in the table, and after some time auto vacuum sees that okay, the number has gone down, and then it goes and also does in place update in PG database. After that you will be out of your wraparound problem, so you really don't need to do it. There is one case where this doesn't work, and if Postgres decides that it can truncate the table, then the truncate will fail, because truncate needs transaction, because it updates some system tables transactionally. And for that, in Cloud SQL, we actually made a patch that it avoids truncating if it's close to wraparound. And also in mainline Postgres, this was fixed in version 14. There was lots of activity. I think maybe even the activity started because I sent about this thing that you really don't need single user to hackers, and there was some discussions, and after that people found other things that can be improved in version 14. So in version 14 you can always run vacuum even if you are in wraparound, and there are no cases where it would fail. In earlier versions, in 10 and 11, no, I think in 11 and 12 and 13, you can manually run vacuum no truncate, or truncate equals false. It is not available in earlier versions there, unless you're running Cloud SQL version Postgres. You may need to go to single user mode still for this specific thing. But even there, you would be better off if you did run the vacuum once first in multiple version, because the second vacuum will be very fast, because all these helper tables, free space maps and freeze maps, they are updated. So the vacuum in single user mode will be fast. It sees that it actually doesn't have to do anything. It can skip everything, and then it will just go and do the truncate, and you're out of your wraparound. So you should do the first vacuum in normal mode, then get this error once, and after that go very briefly to single user mode to fix your problems.
It's very interesting. So like the main idea, try to avoid single user mode, but in some cases you will go there for briefly. This is interesting.
Yeah.
Like
for Cloud SQL, we have already patched it so that you don't need ever to go there. But for older versions of community Postgres, you sometimes need to go and do some fixes. For example, even the dropping of the temp table, you can't do in normal mode. Okay. This was one that is kind of specific to Cloud SQL. If you want, you see that the vacuum is slow, and then you would want to have a better tuned version running. If you just update the tuning, then it's not picked up by vacuum until the next vacuum is started. So what you could do, you currently could set the new flags and then restart the system, and then it runs your tester systems. But what we did, and you can cancel the backend if you're a super user, but in cloud we don't give super user to normal users. So we have some semi-super user type thing that can do some, but not all things in cloud. It is kind of just how the managed database works. It seems to be very similar in all others also, that there are some functionality, super user functionality that is held back. But yeah, what we did, we have a patch that says that if the process is running vacuum, then any user with PG signal backend can kill it, because it seems like a thing that is safe to do, because it really doesn't affect integrity, or you can't get any info out of it. It just is for restarting the system in a quick and easy way. And this is the main thing we did. We introduced a special maintenance mode. When it's set, then you will get 500,000 more transaction IDs in this session. So you say set Cloud SQL.enable maintenance mode equals true, and then you get 500,000 more. So you can actually do everything that needs to change tables, you can do there. And just because there always will be some people who will set it and then they will run their normal workload and then run in a few minutes again in the wraparound, we throttle it. So I'm not sure if it's 1 second or 10 per second that we can give out in this case. So to encourage people to use this responsibly for dropping tables, dropping indexes, doing other useful things to get out of wraparound. But again, it is something that we also hope to get in the main Postgres. So it seems like a good thing to have for avoiding some more drastic measures like actually restarting the system in single user mode. And this currently it's also only way to remove the stuck temp files once in wraparound without going to single user mode. There is another thing that is not really that much about wraparound, but internally Postgres uses the version of alloc that is designed for other large objects and so on, which has a 1 GB limit. And so if Postgres allocates the space to collect the dead tuple IDs, then it uses this allocation, and it means that you can collect only 1 GB worth of transaction IDs. And I think it was 178 million or something like that, which sounds like a big number, but if you have multiple terabyte size tables, then I have seen cases where this limit was filled more than 10 times, so that the vacuum needed to clean up all indexes, run the index cleanup phase 10 times over all the large indexes. There was some discussion about actually allocating larger allowing allocation of larger, because modern databases sometimes have not gigabytes but terabytes of memory. So sometimes you really would like it, but this patch got some discussion, and after about a year or two, it was dropped. And it didn't go anywhere, mainly because currently we also over allocate this space. We allocate as much as we think could possibly be used. So most of the time we allocate more than we need. And for that, I have actually tested this. My solution would be to do the initial collection in a file. So you will only allocate once you have done the collection, and then you can allocate exactly as much as you need. At some point, we may even want to make this as another fork of the table file, so you can kind of stop and restart your vacuum process later, and then make it kind of interruptible or startable in an easy way. But basic thing is that it would make it much easier to advocate for allowing larger collected data, and maybe basically better optimize how you use memory and how you use other resources at that time. So it is, but yeah, I have done some tests, but this is not gone anywhere. And again, it is a problem that doesn't come up too often. So there are always other priorities. But if somebody wants to work on this, it would be very nice if this also got solved. Okay, and then that's it for me. So any more questions?
Yeah, all right. Yeah. Well, thank you. It's very interesting, and I've learned unexpected things right now for me. So as we already discussed with Ilya, it's very hard to find unknown things around this problem, but around vacuum itself. But obviously, your material has them, those things. We have a question in chat again about MVCC in Postgres. How about the concept of huge pages and super pages? So, for example, on large DML plus rollback, instead of billions of xmin xmax updates, we could have only thousands. Was this idea explored by Postgres developers?
I haven't seen, I don't remember at least not any discussion that went very far. Maybe something has been brought up briefly by somebody just as an idea, but I don't think anybody has made any real effort to get something like this in. But yeah, it looks like now that we have pluggable table storage that could be part of some of new storages that people are writing. So it could be, again, interesting idea for analytical data that is loaded in large chunks.
It actually doesn't look very easy to implement, because this concept is familiar for us from the point of view of operating system, and there are actually huge pages which are dynamical. They are not that successful as just huge pages which we pick like a piece of shared memory or something like this. So the second one works quite well. The first one, the transparent huge pages, when you use a lot of memory, it's actually very prone to do something with this. And in case of database, you will need to dynamically decide where to use them, how to use them, etc. It would be actually very painful to implement, I guess.
Yeah, I also think that it's as an idea of keeping less bookkeeping info per tuple, which is not just the xmin xmax is part of this bookkeeping info. There are some others. It could be for some storages, and I think there is some either Toast or I think Greenplum has, not Greenplum, but there is something related to Greenplum, but Apache does. I don't remember their name, but they have also kind of outside the main Postgres development, they are using other storages like Avro and I think the other big data type storages underneath. And there they are not very good in the OLTP because they are not designed for that, but they almost kind of remove the part about visibility MVCC. So there, yeah. For poor analytics, it seems to make sense to have this removed or have it once per larger number. But the whole Postgres storage is something that I think also you can do a lot there because the storage format, the basic storage format has stayed the same for last 30, 40 years already. And the computers were very different by the parameters at that time when it was sorted out. So there, and also just the storage overhead. I think there are possible innovations there, but I haven't seen much discussions addressing this specific problem.
Yeah. Thank you.
I guess no more questions. So
yeah, but I can actually ask one very finalizing question. You touched this topic in your talk actually. Postgres went a long way with vacuum and auto-vacuum. And initially this entire MVCC model, which requires auto-vacuum in some way, was considered like a very beneficial thing. Then more people from Oracle world came. They started to say, well, it's pretty much a bug. So basically, like undoing Oracle way is much more convenient, has no that limit amount of workarounds like after vacuum. And now practically Oracle implements a flash recovery area, continuous data without any end, time traveling and things like this. So pretty much now it also became like a very progressive feature of Postgres. What do you think? Is this implementation of MVCC, which requires auto-vacuum, is it a bug or a very feature which is really ahead of its time?
I think it's a good, clear design from the beginning, which even has kind of proven itself to be good design even for initially unforeseen purposes. And these discussions about replacing it to Oracle style or MySQL InnoDB style thing with rollback buffers, it solves well a small subclass of problems, but even there, I don't think it's the best solution because it puts all the housekeeping work in the main path, which means that you actually are doing vacuum as part of update. In Postgres, you can split them apart, and I think in one of the slides I also had that it's because this Moore's law is kind of coming to an end, but we can have more parallelism. It still would make sense to do it at least in a separate thread and not try to do all this in the main thread. So I would say that it's actually a very good design, and we should just even if we try to get this Oracle-like MVCC, we should still keep the basics the same as it has been because simplicity and simple things are easier to optimize, easier to argue about, and also because it's easy to keep the housekeeping work in a separate work stream.
But don't you think, for example, if you consider indexes, they have references to page, right? And if we consider regular non-hot update, which will put new tuple to probably new page, and index will need be updated too. This means that, for example, if in the case of commit, we will need to rely on new pointer, new reference to new page. In the case of rollback, we will need to keep the old reference. In my impression that Postgres is very pessimistic, thinking that rollbacks are to be happen much more often. Because of course
it's not pessimistic. This specific case, yes, if you are only doing inserts, if you at the same time you have also other processes that still want to access the old ones, then this is the best design, because you don't need to go to chase the old versions in some rollback pages.
But if you think about those who need the current versions, okay, you still think that new version, like you still not think about future enough, I would say.
No,
because in the future, if we have more commits and updates in the future, new location will be more important. In Postgres case, in Postgres MVCC case, it's very heavy operation to shift our attention to new page, right? And in the case,
if this were the main case, I would actually think about putting the transaction ID in the index also, so that you could, if you had lots of parallels. Otherwise, it gets resolved in the first access to dead tuple, because then Postgres sets flags in the index, and it still bloats index, but you are not going to do lookups anymore, because you know that this index pointer points to a dead tuple.
Okay, not everything is not that simple, right? Okay.
Yeah, basically, both of them have their cases where they perform better, but I think it is possible to improve Postgres MVCC without fundamentally changing how it works.
Yeah, and improvements in the area of indexes, B-tree indexes, recent improvements over the last few years proved this. Exactly.
There are lots of work also gone there, so that. But
right.
I think I think fundamentally keeping the housekeeping work out of the main work path is a good idea.
Good. Okay, so I think this is it. I enjoyed it a lot. Thank you so much. Thank you so much, Hannu. I enjoyed it a lot. Great material, and I'm going to share it. And I ask everyone who watched it also to share, because I think any DBA will benefit from learning these small, very rare, probably never happening things. But of course, you at least you will need you will know that where to look at, what to watch if you happen to be there, and that's a bad situation of wraparound.
Yes, and they also actually want to avoid them. So it's if you want to avoid something, it's better you know about them.
Better to learn here, not in production, right? Yes. So thank you once again, and everyone, please don't forget about all the buttons, like, subscribe, share, and so on, comments. It will help to grow the channel. Thank you so much. Bye-bye.
Thank you.
Thank you.